Alright, so today we're going to be looking at polynomial division with remainders. The learning target is I can divide polynomials. So before we start talking about dividing with polynomials, I want to review with you how to divide two whole numbers, which is something you may have remembered from elementary school using long division. So what I'm going to do is 5 divided by 4. I'm just going to go over a quick review of the process because polynomial division is going to have a very similar process. So we have this long division symbol that we're going to be using. The number at the bottom goes on the outside, so 5 divided by 4. How many times does 4 go into 5 is the basic question. So 4 times 1, right? So usually we'd be like, okay, if we didn't know it, 4 times 1, you bring down the 4 and you subtract. Then what you do is you subtract. So 5 minus 4 is going to give you 1. All right. So because the 4 cannot go into 1, right? Usually what you would do, right? This is you would put like a decimal point and then a 0, bring down the 0, and then you end up getting a decimal, right? But we're not going for the decimal route. We're looking for the mixed number route. So how we write this as a mixed number is because 4 can't go into 1, we're going to rewrite this as 1 and 1/4. And that's going to be our kind of focus today when we're dividing polynomials. But before that, I do want us to understand that this 1 and 1/4 is actually the same thing as saying 1 plus 1/4. So this representation means this. It's saying 1 plus 1/4. And if you were to put that in your calculator, it's 1.25, which would be the answer if we're doing 5 divided by 4. So this is going to be the format that we're going to be taking a look at today when we divide polynomials. Another thing to kind of remind you all is if I was to convert this 1 into 4 over 4 so that I have a common denominator to add the two fractions, I would get 5 over 4, which is again equivalent to my next mixed number format 1 and 1/4. These two are equivalent. That's just something I wanted to point out, of course, because it brings us back to our original problem. So you could see this equivalency. So 5 divided by 4 is 1 unit and 1/4. This is going to be our focus. All right, so let's take a look at polynomial divisions now. So on the problem to the right of your paper there, we have this right here. We have x to the fourth minus 6x third plus 18x minus 1, all divided by x minus 2. So I went ahead and I already wrote it with the little division symbol here. So I have x minus 2 divided by, and then my whole numerator right there. So we're going to go ahead and try to look at the process of how we divide polynomials. Before we get started, there's something I need to point out. If we look at this polynomial right here, we have the fourth power, we have the third power, then it jumps to the first power, and then here's 0 power because there's no x variable. What's missing here is actually x to the second power. So in order to divide polynomials with long division, you actually have to include any missing variables like this. So I'm going to show you. So because the x squared is missing, I just put it in right here in the middle, right after to the x to the third and right before the x. I put it as 0x squared. So we have to do this because you'll see it's going to be matching up. So it's just a step you got to add in there. So be mindful of that. If you're missing a variable, go ahead and add it in, but make sure that the number in front of it is 0. It's actually 0x squared is like adding nothing. So algebraically, it makes sense. All right, so now comes the step. Well, I don't know how many times x minus 2 goes into this very long polynomial. What are we going to do? This is what you're going to do, and here's the steps. You're just going to take a look at the first term here in each polynomial. So here I have x to the fourth, and over here I have x. So, I asked myself, x times what will give me x to the fourth? X times what will give me x to the fourth? A little bit of thought here, but x to the third power, because x to the third times x will give me x to the fourth. So what I'm going to do is up here, right on top of the x to the third term, I'm going to go ahead and put what I'm going to multiply, x to the third. And again, that's just what the steps that I did here. I just asked myself x times x to the third is going to give me x to the fourth. Good. Now the question is, well, what am I going to subtract down here then, right? That's the process of long division. What you're going to do is you're going to go to the side of your paper and you're going to do some work. So what you're going to do is you're going to do x to the third times x minus 2. So here's my side work. X to the third times x minus 2. Distribute, and you get x to the fourth minus 2x to the third. So then we're going to go ahead and take that outcome and we're going to subtract. Notice how I'm subtracting with parentheses. That's because I'm subtracting this whole term, not just subtracting x to the fourth. I'm also subtracting the 2x to the third. So you've got to put your parentheses because it's going to distribute. So super important. And again, these are going to be color coded so you can see what I'm doing. All right, so x to the fourth minus x to the fourth, that cancels out. That's just 0. X to the fourth minus x to the fourth is just 0. Now here, minus x to the third plus 2x to the third. So minus x to the third plus 2x to the third, that's going to give me negative 4x to the third. See that? So super important to distribute this minus sign here. Next, okay, what we could do is go ahead and bring this down. So let's just treat this like, as if it had a decimal. We're going to bring that down. Okay, so now let's ask ourselves the next step. So how many times does this go into this? So again, as I mentioned, the key is to just look at the first term of each new polynomial here. So here I have x, here I have negative x to the third. So what can I multiply x to get negative 4x to the third? So I do need a negative 4, so negative 4, and then I'm missing 2 x's, so I think I should multiply this by negative 4x squared. Negative 4x squared times x will give me negative 4x to the third power. So I'm going to go ahead and put what I'm going to multiply right above the squared because it's a squared term, see? Minus 4x squared. Now I'm going to go ahead and figure out to the side here. I'm going to go to the side and start to multiply negative 4x squared times x minus 2. And that right there is going to be color coded as blue. I'm going to go ahead and distribute. And again, you want to be super careful. Basically, what people might get wrong here is when you're not careful with your signs, when you forget to, like, for example, here, this should become positive 8x squared, not negative, because negative times negative is a positive, so be careful. All right, so this is my outcome. This is what I'm going to go ahead and subtract right here. Great, so again, be very careful. There is a minus and then parentheses and then your outcome. Now, let's go ahead and start subtracting. So negative 4x to the third minus 4x to the third, because I'm distributing. So minus 4x to the third is positive. So basically what you have here is negative 4x thirds plus 4x thirds. That is 0, right, because one's negative. Great. So now you have 0x squared, so nothing, minus 8x squared. Again, I have to distribute this negative into here. So 0 minus 8x squared, that's going to be negative 8x squared. All right, next step, let's bring down this 18x right here. Great, so now we're going to go ahead and continue the process. So now next, let's look at the first term of the new polynomial. So it's negative 8x squared. Here it's just x. So what do we multiply x by to get negative 8x squared? You need a negative 8 for sure. And then I think you need one more x to get the x squared right here. Okay, so let's multiply by negative 8x. So I'm going to put that right here above the 18x. Great. We're going to go to the side, do some work. Again, if you're very quick with these and can do these in your head, you don't got to go to the side and do this work. I am doing the work on the side just so it's super, super clear to you how I'm getting these answers. So I go ahead and distribute, making sure that this becomes positive. Great, this is my outcome. We're going to go ahead and bring that down and subtract, remembering to add those parentheses and distributing that negative. So we got negative 8x squared plus 8x squared, again, because negative makes a positive, so that's 0. 18x minus 16x. So 18x minus 16x is 2x. Let's go ahead and bring down that last one, which is minus 1. All right, so now We're going to find out. So what do we multiply x by to get 2x? I think we just need a 2, and it's positive 2 because there's no negative there. Great. So we're going to go to the side again, multiply our x minus 2 by 2, distribute in there. So we got 2x minus 4. That's our outcome. We're going to subtract our outcome. So we got 2x minus 2x. That goes away. Negative 1 plus 4. So negative 1 plus 4 is going to be positive 3. Super important, right? It's not negative 3, it's positive 3. All right, so great. So woo, it looks like I can't multiply anything by x to get 3 because the 3 doesn't have any x terms. So that is where we stop, and we're going to create our remainder. And as it goes, it's basically, since this can't divide into 3, we're going to just write it as plus 3 over x minus 2, like this. And that is it. This is the answer. So basically, this is what you want to circle up here. I can't really circle on my PowerPoint currently like this, but this is your answer. So basically what we're doing is this whole thing is simplified to this whole thing. So it's super important to get this down. If you still have questions on how to do long division with polynomials, I will have some Khan Academy video tutorials to help you refresh and take a look at some more examples if you still need some help. Otherwise, if you feel that you've got this down, I want you to move on to the other two problems, practicing this, and I'll have the answers ready for you so you can check your work. All right, good luck.